Welcome to Contextual Electronics. My name is Chris Gammell, and this is episode 2 of the Contextual Electronics podcast. Today we're talking to Stephen Hawes, who's a young maker and electronics enthusiast who is building his own pick and place, which is kind of insane, but kind of awesome. And as you'll see, the thematic thing here, now that we're in our episode 2, we can start to draw a trend line. In last episode, we talked to Sophie Wong, who's putting together mechanical and software and electronics. Today, Stephen is also putting together mechanical, electronics, and software, and putting it all together for this pick and place. Not only that, he's much like Sophie in that he documents a lot of what he's doing, and he shows you on his YouTube channel as he's building what he's doing. And I think that's a great way for people to learn. We love project-based learning here at Contextual Electronics. It's an educational program for teaching you electronics, and we also do projects. So let's dive in. Here's Stephen Hawes in episode 2 of the Contextual Electronics podcast. Welcome, Stephen. Thanks for coming.
Thanks for having me.
So, Stephen, can you tell me a little bit about yourself and your background?
Yeah, sure. So, like a lot of people that make things, I realized when I was young that I like taking stuff apart, building things, that whole arc. So I decided I wanted to go to school for engineering. I went to UConn for mechanical engineering. Realized quickly that was not the right choice at all. And I instead should have gone for computer science or electrical engineering. That was more of kind of where I found interest. The classes didn't necessarily dictate what it was that I liked to do.
Yeah. So it wasn't like you lost a finger or something like that. It wasn't like, oh yeah, I had a run in with the bandsaw and now I'm an electrical engineer. You know?
Although that would have been a much better story. No, that is not what happened. No, I had a computer science class my freshman year, and we had to learn MATLAB, and I wasn't a huge fan of MATLAB. Like, I think arrays start at 1 in MATLAB, just right out of the gate. There's your...
What are we even doing here?
That's enough to discount a programming language.
Yeah.
But the professor had us buy a little Arduino kit, and he pretty much wrote... Are you familiar with Firmata, the firmware you can put on?
Yeah. That's JavaScript, right? For robot driving and stuff, right?
The way that if we're talking about the same thing, what I'm thinking of is it's like universal firmware you can put on an Arduino or a microcontroller, and then you just send it like turn on digital pin 5 high over serial. You're kind of abstracting the code out of the Arduino and doing it on a computer and just giving it direct commands on what to do with the processor over serial. It's really cool stuff.
Yeah.
And he pretty much the professor wrote Firmata essentially for this Arduino we had in the kit, along with like a MATLAB library that you could just like send it a little bit and it would make the Arduino do something. And that was it. That's all we really used it for. It was mainly just MATLAB stuff. And I was like, you could do more with this thing. And then I started reading into it and like, what's actually the chip on there and what's it doing? And it just got it's so much more piqued my interest than anything I was doing in class. And I was like, okay, I should have switched my majors like 2 semesters ago.
I'm done. Yeah, I'm not coming out of this one. Yep.
Right. I just had to finish it out, and I'll do the computer stuff, the electrical engineering on my own time. But yeah, so that's like my official schooling background. I did manage to squeeze in a minor in computer science engineering. So I managed to, get a little bit of it in there, but for the most part, mechanical engineering background.
That's great.
Yeah, it was okay. It was a good education, all that jazz. And then after I graduated, I went to work at a company called Deep Local in Pittsburgh. And the way I describe it is like they're like an advertising agency, but instead of making like billboard ads and stuff, they build stuff. They like build prototypes. So one of the best examples is for Netflix. We did this project where it was like the Netflix and chill button. So it was a little wood box with a red button on the top, and you press the button and it would silence your phone, dim your lights, turn on your TV, silence your phone, and order a pizza to your house. It would just like set up all your Netflix stuff for you.
Yeah.
And we didn't sell any of them. It was just like a marketing thing. I got X number of social media impressions. So I worked there for like a year and a half, working like 100-hour weeks, flying to China and India with robots that I built in 9 days, and like crazy stuff, but super fun.
Yeah.
A total blast. And that was like really about like, how do I build one thing really fast that works for 48 hours?
Got it. Yeah.
Like super sketchy. Doesn't matter if it's reliable. I just need to be able to like repair it on site if something happens. And I need to make it in like a week. And that's what I did at that place. And it was super fun.
That's great.
Burned out pretty quick. And then started working at Formlabs, the 3D printing company. And that's the opposite. I'm on the quality team at Farm Labs. So instead of building one thing fast, I have to build a lot of things well. So I kind of got a good,
slow, right?
breadth. Yes. Yeah. Comparatively, incredibly slow. Yeah.
Right.
Still pretty fast.
Quality wise. Yeah. Right.
Yeah.
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 Cool.
So I've had this really awesome opportunity to get this full spread of, how do you make something really, jank, super not necessarily reliable, just bang it out and make it happen.
Mm-hmm.
And then also like really like long lifetime tests and making sure that things are reliable and all the different environments things could be exposed to. So it's been a really awesome opportunity to have that whole spread. But yeah, so that's kind of, at least professionally, like job wise, that's what I've been up to for the past, 3 years or so.
That's great. Then how is this? So you're known because of your YouTube channel and you're building this really great pick and place, which we'll get to. How did then this, combination of, quality work and prototyping work, how did this lead into everything else that you do and sharing with the world?
So it's kind of been separate from my job wholeheartedly. Like I've always just kind of done extra stuff for fun because I wanted to build things. And so in 2018, I think, I did a small Kickstarter for something I called the Glow Tie. And it's a light up bow tie that puts out its own Wi-Fi hotspot. And you can connect to it with your phone and it will host a website from the bow tie and it will send out that webpage to your phone and you can control the colors and the patterns of the lights. It has a little UI on it. And it was like a little gizmo I made for my grandpa and I showed it to some friends and they're like, you need to sell this thing. I was like, I don't know. And I kind of thought about it for a while and I finally decided like, whatever, I'll make a nice low, like metric for having to, how much money to make, for the Kickstarter before it's funded.
Right.
And I made it and I had to make a whole bunch of them suddenly. So I had to make like 100 of these light up bow ties of all things.
That's always the problem when you like hit the goal and then you're like, oh, I have a lot of work to do now.
Exactly. Like that's just the beginning. Once you get there, it's like, oh wow, now I have to make a lot of light up bow ties.
Yeah.
So, and then I had to dive into it and I had to make 100. And 100's a real weird number because it's not like you can bang them out in a weekend, but it's also like it definitely doesn't justify like hiring a CM. And it also is kind of borderline of like getting an assembly service too. So I did them all by hand. And it took a really long time. I soldered like 2,500 components by hand or some crazy number. It was just like so many WS2812 LEDs. It just took a lot of time. And after that, I got them out the door and I shipped all of them. And then I was like, all right, how else can I do this? There's got to be a better way. And I got quotes for assembly services from like all the big board shops. Arm and a leg, way too much money for like, until you were getting up to like 5,000 to 10,000 units, just wholeheartedly not feasible, at least for my budget.
And you were looking domestically mostly or overseas as well?
I was looking both. Yeah, domestic and overseas. And it was pricey. It was not what I want. At the very least for the amount that I felt like I could charge for a goofy gizmo, like a light up bow tie. There's not a ton of overhead, like it was tough. And then I looked into like buying a pick and place and, they're very, very expensive.
Yeah.
So I kind of shopped around there a little bit and I looked for some options, but nothing really panned out. And I was like, what? This thing is fundamental, like as naive as I could possibly be. It's just an XYZ CNC gantry. Like, how is it fundamentally any different from a 3D printer? Like, this is a solvable problem. So then I started diving into trying to make my own. And, of course, the deeper I get into it, the more I see how unbelievably not simple it is to do all that stuff. But, that wouldn't change anything. The fact that I'm glad I was that naive diving into it because otherwise I probably wouldn't have done it. And I've really enjoyed working on it. So
yeah. Well, and I think that your videos, you show, kind of the different elements of it in here. You've got feeders, you've got solder paste, you've got indexing, all of the, the key problems that are, any pick and place has to deal with. And then you're kind of bringing those to the forefront too. It's like you're documenting the pain of pick and place manufacturers everywhere.
Yeah. I would love it if there were some engineer that worked at a pick and place company and they're watching these. They're like, yeah, isn't it a hard problem? It totally is. That's a tricky one.
Right. That sucks. Right.
Right. And of course, people that are also watching me go and doing all these things and they're like, oh, that's not going to work. Oh, that's, people who know way more about these machines than I do. And they have all this knowledge about how these machines actually operate, people who use them every day. And they know right out of the gate, the first line I say in a video and they're like, no, that's not going to work,
Yeah.
But that's the benefit of putting it out there. If I didn't put out a video, then I never would have gotten that information. It stops me in my tracks if I'm doing something wrong, kind of outsourcing the general populace's thoughts. I'm just some goofy kid, instead if there's, all these really smart people that are experts in their field, they're like, no, Steven, you should do it X, Y, Z. It saves me a bunch of time, Yeah, it works out pretty well.
Well, I think there's a little bit too much of a, well, that'll never work culture on YouTube in general. So I'm glad that you're doing it anyways. That's the important part, is the doing it anyways, and showcasing a lot of this stuff. So as you're doing this, what are you learning? I mean, you mentioned, you have a background in electronics, you have a day job that is based around electronics, but you must be learning other things here as well.
Yeah, I think, there's some really specific technical things. Like I had never implemented a buck converter on a board by myself. I had used those Pololu modules and just with the header spacing, just dropped them in there, just call it a day. I've used linear regulators all day long, but I've never made my own buck converter on a board. That was something that I had never done before. I integrated a USB hub into the most recent motherboard, so you can plug all the webcams directly into the motherboard, and then just one clean cable comes out. So there are some technical things that I'm doing that that I've been learning in the process. But the things more than anything is project management, because there are people that are putting in PRs, and a lot of people that give me advice in the Discord server that I have around the YouTube channel. People will pop in and be like, you should use this protocol instead. And, why are you doing it this way? You should use this kind of chip, XYZ, all the different advice. And trying to manage all of that stuff has been easily the most challenging part of it. Responding to all the people that are giving me this good advice, and, responding to issues on GitHub. A lot of people are making them themselves. And they're like, hey, look, I'm having this problem with this part fit. Managing all of that has been definitely the biggest learning experience. Obviously, there's a bunch of technical stuff too, but that's been a big part of it.
And can you explain what a PR is for people that don't know?
Oh, yeah, sorry. A PR is a pull request on GitHub. So the whole project is open source, the whole pick and place project. I have it in a GitHub repository, and people can what's called forking the project, which is pretty much copying it and making their own version on GitHub. They can make changes and then kind of go back to GitHub and say, hey, Steven, do you want the changes that I made? And then I can choose to accept them or deny them, give them feedback, whatever. So I do have a lot of people that have forked the project, filing a PR or a pull request saying, hey, please take my changes. And going through and look at those has been a significant chunk of time.
Yeah, I believe it. Yeah, and that is kind of like the merging of software and hardware too. It's that putting stuff on GitHub kind of pulls in those kind of software methodologies, whereas in the old days it would have been, unless you're working at the same company, walking down the aisle to hand someone a revision on their paper schematic. It's like, okay, you're not going to get that from people halfway across the world, like I'm sure you are.
Mm-hmm. Yeah. It's also tricky because a lot of the changes that people are requesting to make and are systemic things. They're what is the way that you talk to feeders? What is the protocol or the electrical standard that you're using to talk to feeders? And that's a huge upheaval of the whole system. So I feel like it's really going to become useful to have people filing these things once there's kind of some bare minimum established. This is what's not going to change. All the edits can happen up from here, but this bare baseline is nothing can change below this set standard.
Okay, so for people that are beginning electronics, which is a lot of people that are watching the Contextual Electronics channel, what is a pick and place machine? Why would you use one? And then, let's kind of work our way into it from the perspective of how you got into it, right? So you said, hey, I think I might need a pick and place machine. I might build one. But when you started looking at pick and place machines, what was it from your perspective? And then how did you start dissecting it and building up your own?
Sure. Yeah. So a pick and place is effectively something that will assemble circuit boards for you. So when you get your board made at a board shop, you have this kind of panel of fiberglass with effectively what's a bunch of wires running through it. But you need to actually put the chips on there somehow. You need to solder the components onto it, and putting them exactly where they need to go for that to happen is incredibly tedious and takes a ton of time to very precisely place all of them. And that's what I had to do for the Glowtie Kickstarter. It took me forever with tweezers and sitting there at my bench and soldering them all on. So I wanted to find some way to have them automatically be placed onto this board and then be soldered with what's called reflow. So you can get this goop called solder paste. And when you put this goop on all the pads on the board, and then you put it through an oven, it will literally melt into molten metal and it will solder the components in place. which is really, really cool stuff. It's so fun to watch it reflow once you put it in the oven. It's very, very, very satisfying.
Yeah, that's great.
So if you put all the paste on the board beforehand and then you place all the parts onto it, you can just put your PCB literally into a little oven and it will solder all the parts magically for you. So I wanted to find some way to have this placement step, which I had to do manually.
Right. You were doing it with tweezers, and you wanted to basically build a robot that was robot tweezers effectively, and take yourself out of that equation.
I like that. They should really be called robot tweezers. That's a much better name.
Right. Well, they use it. So I guess they're air tweezers, right? Because they often use air to create suction and then create puffing force and things like that. And then the rest is what? So it's XY gantry, like you alluded to, like a 3D printer for people that are familiar with those. But did you have experience building like gantries and robots like that? I mean, was that something you had built in your past experiences?
Yeah. So I had built a number of 3D printers before this. I also, at Deep Local, I had to build a lot of random XY gantries for random projects of, different things. So I was pretty familiar with like making a minimal CNC machine. At the very beginning, I didn't want to have to do that. So I went with an open builds design. It was called the Acro 55. And it was pretty much just like an XY gantry. It was a really great XY machine. It didn't have the Z axis, but you just buy this kit for like $350, spend a couple hours putting it together. And you could move a head around with some G code. It was fantastic. So I used that as kind of a bare bones, just to kind of get a feel of how picking and placing worked. Like you said, the way that it will actually pick up the component is with a little bit of negative pressure. So there's a pump that pulls some suction through a tiny little tip, and then that comes down, grabs the component, and picks it up. I had done a fair amount of it before. I also took a lot of notes on how the open builds machine worked, and I used a lot of that as influence of how to go about designing my own.
Mm-hmm. Yeah, I really like that there is a mechanical element to all this, right? So you're basically merging electronics. In order to build electronics, you're merging electronics and mechanical and software, and in order to make this machine that makes more electronics. And there's always that dream of the self-replicating machines that build machines. Obviously, that's a very difficult thing to do, but it's very enticing, I think. And so then how does the mechanical element play in? Like, how much mechanical knowledge do you need to have in order to go and build, to get started on this build?
A fair amount. I mean, I would say probably the most mechanical knowledge that I had to have was about how it would work with FDM printing. So my whole goal with this machine is to make it so any punk like me that wants to do a Kickstarter for 100 glow ties can do it. And it's not going to cost too much money. It's very accessible to do. So I want this thing like anyone with a 3D printer and a few $100 to spare should be able to print out these parts and make this thing themselves. So all the parts had to be printable. That was like my number one thing, is like it had to be easily made by someone with a random 3D printer. So making all the parts such that they were printable and didn't use too much plastic and use things that were readily available by consumers and not like, huge bulk orders of this really weird aluminum extrusion, and decoupling it from me. So it's not like I could have a monopoly
Steven sells the kit and you have to buy it from him or else.
Yeah, that's not what I'm about. Like,
so it's more like you're trying to build like the Prusa of pick and place machines.
I would love if that's what this turns into.
Yeah, that's great.
I would be honored if that is the way that it is considered. I think that would be fantastic. But yeah, I want it to be so that anyone can just buy some stuff online and make this thing. So designing it for that was hard. How are the parts all going to be easily printed, even with machines that have really bad tolerance if your printer is not dialed in? If you could still find some way to make the part work, even if the dimensional accuracy is not great, and that's another part of it. So that was probably the most difficult thing. It also has to be really precise. It is placing things with like really, really tiny components. Precision is the name of the game with this thing. So having to make sure that that's considered is a big thing too.
Yeah, well, it sounds like you were, like you talked about with the pull request, it sounds like you have to make design decisions that are around, what this will or won't include, but it also sounds like, you're creating the specifications. So what are you hoping for your alpha beta units to actually be able to do in terms of part size, placing, how small of a component do you want it to be able to place initially and then eventually, I guess, too?
So before I even started working on this whole project, I set out like a like a burn down list of like all the features this thing absolutely had to have. Otherwise, I did not consider it a success. Okay. And right out of the gate, I said, if I can't pick and place 0603, it's not worth my time. Great. If you go any bigger than that, it's just too big. And I know a lot of people use much smaller. Like 0402 has been a big push. A lot of people have said they want to use 0402. I just stick with 0805 for all my designs.
Yeah. I do that because I have a kit of a bunch of values at home, and I really want to be able to like swap it out and like be like, oh no, I got the wrong value there, and then just go open up the case and grab the right value.
Right. If you can just remove that variable in your mind, it makes designing so much easier.
Right. Until you then you switch to 0402 and you're like, oh, I don't have a kit anymore. I better get the right values when I buy my parts.
Right. Yes. Yeah. Yeah.
Could you explain the dimensions as well? Like, so what is 0603, 0402? What are those dimensions for people?
Oh, yeah. So 0603 and 0805 are like common terms for the dimensions of small passive components. So typically when you think of a resistor, it's like kind of that cylinder thing with the leads coming out the side. But when you put them on a surface mount, when they're not actually going through a hole in the board, they're just these adorable little rectangles with two leads on each end. And 0603 is literally saying how big that rectangle is. I think it's metric, right? Is it like...
It's actually imperial. Well, so the traditional is imperial. They actually list... So if you go on like DigiKey and Mauser now, they list them as both, which is one of the worst things, I think, because... the discrete viewers, the discerning viewers out there will note that 0201 and 0603 are the same size in imperial metric. So if you order 0603 metric, that's an 0201 imperial.
Oh no!
And so traditionally, everything is listed in imperial. So 0805 is 0.08 inches by 0.05 inches. Okay. And 0603 is 0.06 so 60 mil. So mil being a thousandth of an inch. Sometimes it's 60 mil, which would be 0.06 inches. Okay. And people who are metric and listening or watching are just like, it's such a dumb system. It really is. Yeah. I'm personally like, except for PCB traces, which are still spec'd in mils, and then components, which are still spec'd in mils. Everything else is metric for me. But yeah.
Yeah, silly, me too. I sometimes I even switch to millimeters for traces. I just right. I know it's like, a 6 mil trace space is like what a lot of board shops will do. And I think they go down smaller than that sometimes too. But I just know what millimeter width that is and what it converts to. And I just set that as my minimum. And
you do 0.25, 0.2, 0.15, and it's close enough. And as long as you're above what they're saying, if they can do 3.5 mils and you do a 0.15 is like 3 point some mils. Yeah. Or you could just look at the converter. In KiCad, it shows you right there, which is what I really do. True. Like, let's be honest.
Yeah.
Yeah. Well, that's great. So you're now combining the mechanical and the electrical and stuff like that. So now you've decided what it's going to look like. You've decided what some of these specs and what it absolutely has to have. Oh, you were going to list more of these actually. So what are some of these other specs that you were talking about? It has to have A, B, C, D.
Some other ones that were really important to me were how many feeders it can fit. So the picking and the placing is only one half of the equation. That's actually taking the part and putting it on the board in the right place. But another huge part of this is serving up those components to the nozzle. So it actually has a constant source of parts to pick and place. And that's done with a little gizmo called a feeder, which it's so cool. They will pretty much, electronic manufacturers years ago decided that they were going to put components in this tape. And it's just this long strip of tape that has all these little pockets in it. And the components are embedded in there at a very metered, precise spacing along the tape. So pick and place manufacturers everywhere could design their feeders around this specification, which is so great. It's such a good standard. I love that this exists. And feeders will pretty much take this tape and move it forward, very precise increments. That's pretty much all it does. It just moves the tape forward and serves up a new component for the nozzle pretty much. So I told myself, if I can't fit 30 feeders on this machine, there are a lot of designs this is going to exclude. If it doesn't have the ability to hold 30, people that have boards with, 30 or 28, 29 unique components aren't going to be able to use it for populating their board. So I really wanted at least 30. It's probably an arbitrary number, but I just wanted to pick something that I could stick to.
Yeah, so that's the crossover is however many unique components there are. You might have 100 components on your board, but if 29 are unique, then you would still be okay to do this on your pick and place, because you might have 20 of the same value that it just goes back to that same feeder over and over and over again. But then it overall, there's still only 29 total uniques, you're saying.
Yeah, exactly. That's totally true. So like a 10K pull-up resistor is a great example of something that like it's probably going to get used a ton. That one feeder can just index a whole bunch of extra parts, and the nozzle will happily carry them away off to all the different places it needs to go on the board. So it is just unique components. And like it is a hobbyist, small business like scale machine. It's not a really expensive industrial thing. So people would have to design around some of these constraints. Like you'd have to be aware that it can't have more than 30 unique components. You can't design it with parts less than a 402 or a 603, whatever it ends up being. But that's the case with a lot of things like FDM 3D printing, desktop, PCB milling. You kind of have to be aware of the medium with which you're using it for. So if it has those things, I feel pretty good about it.
Yeah. No, I think that's good. And I think one thing, I had talked to someone who had a overseas manufactured pick and place machine. And I was like, well, why wouldn't you just get like a more expensive machine? He's like, look, I could get 6 machines for the same price that I would get, one, refurb machine here in the US. And I can just buy 6 and put them in a row, and then have, if I only have 30 feeders on one, I can place the 30 unique components, slide it down the line, place another 30, slide it down the line. So if the costs are right, you could do something like that, or you could set up similar situations. So what are you, speaking of cost, what are you targeting for the cost of this pick and place?
As low as humanly possible. I want it to, like, one of the original goals is just making it super accessible and easy to make and modify and do all that stuff with. So I want to make it super, super cheap,
Okay. And so what are we at right now? What are we at right now?
$450 BOM cost for the base machine. And most of that is just aluminum extrusion, which I bought on Amazon, which is probably not the best place to be buying cheap aluminum extrusion.
Sure. Yeah, but that's good. That's a good baseline. I think that, like, and I have not seen I think there's some decent hackable pick and place machines that are 5,000 or so, but they're not, going to be great. They're not as modifiable, and they're definitely not open source. So all those things definitely are in your favor. And they're not as fun to watch someone put them together, honestly, too. So
true. The trifecta of like cost, speed, and reliability. People have brought that up with me quite a bit about this project, and I've wholeheartedly, planted my feet in the cost and reliability. If it's, speed, cost, and reliability. I'm punting on speed, because being able to assemble one circuit board overnight instead of 0 circuit boards overnight is a much bigger change than assembling 5 circuit boards overnight as opposed to 1. And hopefully it'll be way more than that, but you know what I mean?
Yeah, that's great. And I think, as far as automation goes, it's doing it low and slow. As long as it is reliable, and that you're going to wake up in the morning to a finished board, that's a great start. The tough part, of course, is sleeping through the sound of a pick and place machine. Don't put it below your bed. So what are some of the lessons you're learning then, as you're, so contextual electronics is all about like people coming into electronics and learning more about how to actually apply it to the real world. You have background in electronics, but you are very much applying a wide range of electronic components and assemblies to go and build this real world thing. So what are you learning as you do that, as you build out this pick and place?
A few things. One is that having standards across a project is just so unbelievably helpful. So one of the best examples for this, we already kind of talked about using all 0805 components, simplifies things a ton. I also just decided to stick with the JST XH series family of connectors across the board. Like everything on this is going to be XH. And I don't even have to think about it. I can buy 5,000 crimp things, like little crimp connectors, and I don't have to worry about mixing them up. I know every crimp I have is XH, and I'm good. So things like that remove a lot of the considerations you might normally have to make. It just removing the number of things you have to think about helps a ton, and standardizing things in that way has been a big way that I've been trying to do that.
Okay.
Another big one for sure is having a big enough factor of safety on pretty much everything you can put into a board. So whether that's reliability of communication, if that's current draw, like speed of the microcontroller. It is better to spend a little more money and spend a little more time and a little more work with the design and make sure that you have a really, really nice factor of safety over what you're expecting from this thing than to try and cut it close and really, nickel and dime here and there. It's better to just do it right. Pretty much always.
Right. So you're saying like if you designed in maybe like an AT-Tiny 84 or something like super cheap, super small, super compact code size, you'd have to use a lot more time. You have to spend a lot more time to actually go and optimize to fit stuff in there. Is that kind of the idea?
Yeah, and also like if I decided down the road I wanted to add a new feature to the feeder or to the design of this thing, is it a software increasable change? Is it something that I have to spin up a whole new microcontroller, a whole new board for, or can I just write a few lines of code, push it out to the GitHub, and people suddenly have this shiny new feature on their board? So that's been another big one, just deciding to go high for all of the metrics that might be a limitation.
Right.
And the last one really is having extra things on the board that are free, because there's no difference between if you put 5 headers on a board versus 1. It's not like it's going to cost more. It's really just about the area of the board. It's free to add things like selectable jumpers on a board. Like maybe, like I don't know for sure if connecting the 5-volt rail from USB to the 5-volt rail of the buck converter is going to be a problem. Might as well just put a jumper there. And if it is a problem, I just cut the trace and the board's great. So having things like that and giving yourself options. There was a great Hackaday article that really stuck in my mind where they had a board design with an ATmega 328, like the classic Arduino chip, with a TQFP and a QFN footprint. And they just nested these footprints inside of each other. So in case they had a stock out on the TQFP part, that one footprint, there was literally just a smaller footprint inside, because it's free to add an extra footprint to the board, provided you don't need the space for routing. Just a cool idea. So trying to add as many of those things in as possible to reduce the number of times that you end up making revisions to a board is tremendous. It's really helpful.
Yeah, I always like telling people zero ohm resistors are real cheap, and the things that they save are really. It's amazing how many times a 0 ohm resistor has saved my bacon in terms of being able to measure the output of a linear regulator. I just pop the 0 ohm resistor off of there, and then I can measure the current going where the 0 ohm would have normally been, or I could put a 0.1 ohm. You put a 0.1 ohm in place, and you measure the voltage across it, or I don't know. Let's say every time I've ever switched RX and TX on a serial line, because that happens all the time. Yeah, I mean that's just. It really can save you. So I pepper those things. You mentioned 10K resistors are the most used on a lot of designs. For me, it's 0 ohms. I've got 30 0 ohm resistors on some boards. And a lot of them are not populated too. That's the nice thing. You can use them as population options, like you mentioned. And there's design for manufacturing, there's design for repair, and there's just general design for paranoia. And that's usually where I'm living.
I like that a lot. That's a good next step of design for paranoia.
Yeah, it'll just save you. Once you feel, I think it's important to feel the pain anyways, right? I tutor students. I talk to other engineers. You got to feel it. You got to understand where that pain is before you start to put. Oh yeah, no, I remember that problem. I should put a 0 ohm resistor right there, because cutting and jumping those RX TX traces is not fun. So
no, it's not. Yeah, a lot of it too, I think, is realizing that the chance that you will get a perfect spin up on your first rev is small. You can really feel like you've done your due diligence with checking your design, looking at your schematic, make sure everything's connected right, and going through all your data sheets. But it's almost inevitable, at least, starting out, you're gonna just you're gonna put out Gerbers that don't work.
You're gonna goof it. Yep.
Yep. And that's totally fine. It's just part of it. And it will kind of just always happen, I think. Every time I have made a board, there's something I didn't think about. It's just impossible to consider absolutely everything, or it would be so prohibitively, it would take so much time, especially when it's just one reviewer. I don't really send it out to someone to look at. I'm sure then most things would get caught, but if it's just you looking at it, stuff's going to slip through the cracks, and that's fine.
Yeah, I think it's all right I think that's an important thing that I learned was to go easy on myself. Everybody makes mistakes. I mean, these days circuit boards are so cheap that it's okay to just spin another rev, especially when it's something that's time insensitive. That's great, because I could just go and redo it. I think yeah, it's important to kind of remember that and go easy on yourself,
Yeah.
And you're spinning up, I mean, a lot of boards, and you're doing a lot of discrete design. So could you kind of paint us a picture of the maybe also tell us about the videos where you talk about the stuff, but the kind of the block diagram of what's in this system. So you mentioned feeders, but what is, and there's like a controller board I remember seeing, but like what else is in the system that it needs to all plug together?
Yeah, so it pretty much, a pick and place needs to have a bunch of stepper motor drivers because you're moving up to like 6, 7, sometimes 8 axes in this machine. So you need to be able to control a bunch of steppers. You need to be able to control pumps. So you need like a big, beefy MOSFET to be able to switch 12 volts on and off and stuff like that. So I originally went with an Arduino Mega with a ramps shield, which is traditionally for 3D printers. It's like it has 5 stepper motor drivers on the top of it. You boot Marlin onto the Arduino Mega, and it becomes a 3D printer magically. And
Right.
it fit the bill for a lot of the things I needed. You just feed it G-code, and then it goes from there. So having a main controller that moves all the axes is an important part. And then you need the thing which is like the 3D printer equivalent of a slicer, something that's actually deciding where to move the head. When do you turn on the pump? What component goes where? And what I'm using for that is this awesome open source project called OpenPNP. It's a long-running project. It's been around for an incredibly long time. And it is designed to be as open-ended as possible such that you can pretty much have it control any pick-and-place machine that you have.
Yeah.
So
yeah.
you load in your position file that your ECAD software will spit out, and you assign, hey, this goes to this feeder location at this place, and it just goes. It goes, you give it all the settings, and off it goes. So I'm not doing any of that decision-making process. That's all being offloaded by a separate thing. All I'm doing is making a controller, which is deciding how to move all the motors.
Got it. So the OpenPNP runs on like a full-blown Linux computer or something or equivalent?
Yes, I think it's totally cross-platform. It's written in Java. It's also open, so you can compile it yourself. But yeah, it's an awesome piece of software. It has like support for webcam, so you can see where your nozzle is, and all kinds of really cool stuff. Yeah, it's very very open-ended.
So then how does that talk down to the ramps board then? So like what is actually that interface? Is that just like a USB to serial connection?
Yeah, it's just a USB cable. So just like with the ramps board for a 3D printer, you have a USB cable going from your computer. It's just talking out over serial. That goes into a USB to serial USB to serial converter to UART, and then that goes in the microcontroller, and it processes the G code that's being sent out over USB, and then figures out what to do with it. So that's what I had for a while, and then I also, when I started adding feeders to the board, Marlin does not have a peripheral on it that allows you to talk to up to 30 separate microcontrollers in an easy way. So I ended up making my own board, which was a glorified microcontroller connected over USB, talking to 4 I/O expanders. So I had effectively like 60 pins on this board that I could control over serial with G-code. And I had it, I wrote my own little communication protocol, very similar to I2C. It was pretty much I2C, but without the addressing, because you don't want to have to set an address in the feeder. If you did that, then if you're running a job and it's all set up and it's moving just fine, and one of your feeders runs out of parts and you want to be able to take it out and put it in, it's not going to know that the system is talking to it because that address is like embedded in the feeder. So I was like, I need something that's going to talk to the slot that the feeder goes into, not the feeder itself. So I kind of made my own protocol thing, which was super fun, but wholeheartedly not the correct solution.
And that's actually a good, for people that aren't familiar with pick and places as well, that they do, the feeders are replaceable. I guess we glossed that the first time through, but they kind of hook in, and then they talk to the main computer, and they can be pulled out, like you said, for reloading and some other things.
Yeah, they're kind of separate from the machine. Some of them are completely unconnected, and the way that they know it's time to move another component forward is there's like an actual like brake beam IR sensor, and it sees the nozzle in front of it. So there's no communication whatsoever. It just sees that there's a broken beam and that the nozzle was there, and it just blindly will move forward and move to the next component, which is pretty cool. It's a good solution.
That's a good idea. Yes, I think... I've never heard about that before, I guess. Yeah, because the pick and places that I have used, which is a very limited set, it seems like you can kind of tweak all the characteristics of the how hard the motor's driving and how fast the things you're pulling, all that kind of stuff. But I guess you don't need that for certain things, so that's great.
Yeah, it's pretty cool. So I
Yeah.
had that whole extra auxiliary board that was controlling the feeders, but then recently I made a whole motherboard which pretty much takes that feeder controller board, it
Yeah.
takes the Arduino Mega and the ramp shield, and it just smushes it all into one big controller.
Uh-huh.
And that's what's driving it right now. I still have so many changes I need to make to it. Like there's so many things I want to edit and change how it works because I spun one up and I saw, oh wow, all this stuff doesn't work. So I got to go back and make some changes. But
Of course. Yeah.
yeah.
It sounds like this is an ongoing effort for quite a long time.
Yep.
So you mentioned every feeder also has a microcontroller on it then. So you created this protocol to talk between them, but how do you then go and program the microcontroller on the feeder? Is that just kind of you set it and forget it?
Yeah, it's a set it and forget it thing. So I currently have firmware on my feeders that will listen to a command over the protocol that I wrote. And then in that protocol, in like the 1 byte that it sends over, it says, hey, I want you to move forward this many pips on the tape. So on the component tape, there's actually little holes every 4 millimeters. And that allows for kind of like a toothed wheel to grab into those holes and drive it forward. That also happens to be how the components are spaced. So sometimes it's one of those pips, 1 4 millimeter spacing. Sometimes it's 5, depending on how big the part is. So that little byte that I'm sending over says, hey, I want you to move forward or backward this many pips, and please send a response. And then it does so, and then it says, okay, I'm good. You can continue moving on trying to pick the parts we completed successfully. So it needs to handle that. It needs to drive a motor. Also, this movement forward of the tape needs to be really, really precise. So I have a little distance sensor in here and a wheel with a whole bunch of holes cut in it. So as the wheel moves around, it's kind of like a like a encoder wheel, kind of. It's weird, but the wheel is actually made out of a PCB. So the PCB has a whole bunch of reflective, like ENIG plated pads on it, and then cutouts. So the reflective sensor will either reflect really shiny off of the gold area on the wheel, or it will shine straight through it into a black abyss, and it won't get a signal back. So as this moves around, I can see exactly how far the wheel has moved the tape forward, and that's kind of how I can do positioning. I have a little PID loop in there, and it just kind of positions, make sure that it has the right position. And that's really all that's happening.
Can you define PID for people as well?
Yes. PID loop is a kind of control mechanism for if you have some signal in and you're trying to control an output that's not a very good definition of it. It's pretty much a way that if you have
self-evident,
if you have a great example of this is like a self-balancing robot, like a 2-wheeled robot, like a Segway. If you know what angle the Segway is at and you have control over the motors, a PID will pretty much let you make the robot stand up. It will take in the signal input from the angle, and it will drive the motors accordingly to control that angle. I think it stands for proportional integral derivative, the PID.
I think so. Yeah, exactly.
So it's just pretty much a way to control the position of something really well. It's easy to implement. There's a whole bunch of really awesome libraries that do it for you. So I have that control in it.
Yeah, that's nice when there are libraries to just jump right in and get something working. Yeah, I mean that's wonderful.
Yeah.
Okay, that's great. And so you mentioned also that there's cameras and vision and all that. So is that all handled on the computer, like through OpenPNP, or do you have to actually interface with the USB cameras as well?
I don't have to deal with actually processing the data from the webcams. So what will happen is the webcams plug into the motherboard, and it goes to a little chip that acts as a USB hub. And it will just feed that right up to the USB cable back to the computer. And the computer's running OpenPNP, and it has a whole bunch of really cool tools using OpenCV, which is an awesome library for processing images and video and stuff. And you can pretty point and click program this OpenPNP, or excuse me, this OpenCV. A lot of open blank terms involved here.
Right. They're very descriptive.
Right. And it will pretty much tell OpenPNP how to look at the component. So the reason that the cameras are even there to begin with is to help position everything. This machine, especially this machine that I'm building, is not going to be super precise. It's made out of 3D printed parts. It's not going to be perfect. So what the cameras will do is they will actually see where the component is after the nozzle has picked it up and it's kind of stuck on the tip. It will move over on top of a camera, and a camera will see, oh, it's exactly offset by 0.3 millimeters X, 0.5 in the Y, and it's offset by 26 degrees. So it will see that using the camera, using computer vision, realign it, and then place it really precisely. So even if the machine isn't absolutely spot on, the cameras will take up a lot of that slack and figure out how to still place them pretty accurately.
That's great. That's great. So then your goal as the machine designer is to accept commands back from OpenPNP and just do exactly as it says. Is that kind of the idea? So like the rotation and adjustment type of movements like that?
Yeah, all of that stuff is decided in OpenPNP. And there is a fair amount, because it's such an open thing, not only open as in, Libra, but also open as in like it's open-ended and very customizable. There's a lot of configuration that you have to do in OpenPNP to get it set up for your specific machine. So it's kind of deciding like, all right, I'm going to allocate this command to make the lights come on. So a great example is Marlin is effectively the firmware that I'm running on the controller board. And I want to be able to control NeoPixel lights for a ring light around the webcam. And I need to be able to have OpenPNP send the G-code command to Marlin to turn on NeoPixels, which is not really something that OpenPNP might think to do to control like LEDs, individually addressable LEDs. So there's this little thing you can just pretty much write whatever G-code when it's like turn on the light. What G-code do you want to send for that? So I have to kind of decide, all right, this is the G-code that it's going to listen for. So there's a little bit of back and forth, but for the most part, it's accepting what OpenPNP is going to send over the USB cable back to the controller, just trying to accommodate for that.
That's cool. Yeah, it's basically, it sounds like you're creating this system, I guess, but it's you're defining all the standards then as well, and you're just customizing it as you need, and that's a really great great exercise, and I really appreciate you sharing all this stuff too. I think it's just so great, and I will of course call out your YouTube channel again. So you have videos about the actual controller that you just posted about. You have stuff about the solder paste and the feeders and kind of all your experiments that you're going through. So it's great for people to be able to go and watch that and subscribe to it to hear about the new things.
Yeah, absolutely, and see other experiments that I try that are definitely not the right course of action. And if you see that, please leave a comment and be like, no, Steven, don't do it this way.
We were talking a little bit before we started recording as well, and you mentioned that there was a loop that you thought it would be good to mention, and I've unfortunately completely forgot what the loop was that you'd said was a good thing to maybe mention to people watching or listening to this. Do you remember what we were talking about?
Oh, I think it was about how I got started in electronics. And I kind of touched on it a little bit with the Arduino kit that I got in my freshman year. But we ultimately had there was like a jack-o'-lantern carving competition in my dorm just a few weeks after I was like, maybe I can do something with this Arduino. So I was like, all right, you know what? I'm going to try and bust out all the stops for this jack-o'-lantern carving competition. And I got you familiar with Battlestar Galactica and the Cylons?
Yeah, that's the kind of like the scanner, like a Larson scanner style LEDs, that kind of idea.
Yeah, exactly. They got the red light, bing, bing, going back and forth. So I was like,
kids from Knight Rider for the olds out there.
Yeah, right. I kind of understand that reference. And yeah, so it will. I decided I was going to try and make a Cylon jack-o'-lantern. So I got my Arduino and I programmed up like manually a bunch of LEDs. Just to ding, 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 go back and forth. And I printed out a Cylon and I carved a pumpkin and all that jazz. Yeah, and, at the end of that, I got back up to my dorm and I was like, I can give something a brain now. I gave a pumpkin a brain. I can automate whatever I want now. And after that, I was like, okay, that's it. I need to do this. It's all over. Yeah. Like, this is way too cool to not spend the majority of my time working on.
Right. And so then your blog too. I mean, so your blog is life is too short to do things you hate. Were you doing things it sounded like you were doing some cool things regardless. So
yeah, it's more about like, don't, settle for doing something that you're not happy with, or, if there's something that is really not doing it for you. Like, the one thing I want to do all day is work on this pick and place and make videos about it and make that what I'm doing, building things and designing systems and stuff. And if I'm not doing that most or all of the time, there's something wrong and I need to address it. That's kind of where that comes from.
So you're using it as a measure on your time and how you're creating things in the world and things like that.
Yeah, for sure.
So what are you planning to build with the pick and place then after all this is done? Now you've done the work, you've built the tool, and then what? You just gonna build more pick and places, or do you have a
I don't
longer term?
know.
Yeah,
That's kind of the rep rap calling, of like building the machine
sure.
with the machine.
Yeah, exactly.
In the last video that I posted, it was about making the motherboard. I got so many comments. Wow, you're soldering the motherboard by hand for a pick and place. That's so ironic. And I was like, yeah, I know.
Yeah,
Eventually,
right.
it'll get to that point, but I think I kind of
We
have
get
to at
it.
least
We
make
get it, guys. You know, you don't have to tell me
it.
again.
Yeah,
Yeah,
right. So eventually I will definitely end up making pick and place boards with this thing. I think it would be pretty meta and pretty cool to do that. And if I do continue to take this project further and ultimately try and sell motherboards and help try and get this out there as much as I can, I
yeah,
will need a pick and place to be able to do that.
yeah,
I might go back to the original project that kind of started this whole thing of the light up bow tie. They're still I have a wait list of some people that still want them, so I
yeah,
might go in and do that, but we'll see. Right now, I'm just doing it because I think it's cool and I want it to exist, and
yeah.
we'll see. We'll see where it
Do
goes.
you, do you have a benchmark for when you think people should or shouldn't use a pick and place? Because I think people who are watching this might be beginners and they say, oh well, I need a pick and place, or I need to use a pick and place. What would be your judgment on when they should jump in and maybe get a board placed?
It depends on a lot of stuff because like in my mind there's like three very distinct tiers of making a product. There's like the prototyping phase where you're making like between 1 and 50, and
Hmm.
that you can bang them out in a weekend in a pajamas in your apartment and with a soldering iron or like a little toaster oven, and that's great.
Yeah,
Then there's like 50,000, 100,000 units, Apple scale. And that's when you hire a CM or a contract manufacturer. And they
yeah,
are owning the whole thing for you. You just give them the design files effectively. It's more complicated than that. But they actually handle the whole process for you. But then there's this really weird, annoying place in the middle where you want to
hmm,
make like 500 to 5,000 of something,
yeah,
but there's no way you want to make that many by hand, but you also really can't justify hiring a CM to make them for you. So I think in that kind of area where you're really starting to make a lot of them at a pace that you can't keep up with for fun, like if you're selling 5 of something a week, yeah, maybe you take a Saturday afternoon and you just kind of, make those for fun by hand, and it's not that bad. But if it really gets to the point where you are trying to make a lot of something for a Tindy seller that really has a lot of things that they're trying to make, or a small business that has a small run of a product that they're trying to make,
yeah.
I think it really could be helpful. But if you're just spinning up a handful of boards, it really is not the right tool for the job. I don't think, or at the very
Hmm.
least, it's overkill. Like it's probably faster
Sure,
to just
yeah,
do it by
right.
hand.
Yeah, and it might be a good academic exercise. I always tell people
Sure.
that are getting started in contextual electronics and similar things that it's, you know, again, you should have the pain first so that you understand when, like, okay, maybe I shouldn't put it. DigiKey told me I should buy an 0201 component. I did it. I bought it. I can't solder it, and maybe I shouldn't do that because even if I have a machine place it at some point, and I have to go and rework it, it's a big pain in the rear. And
Yeah.
so yeah, having that, I think having the experience first, but then eventually, moving your way towards it. It's something that, as you said, when you have a couple hundred to 1,000 units, it really does start to make sense to send out for one, or if you're very brave, such as yourself, to build your own or get your own and
Yeah.
uh, and work with it. Yeah,
Yeah.
that's
But
great.
yeah, I agree. It's definitely down the road for most people. It's like you said, it would be a good exercise to like figure out how to use one, but there's something about doing it by hand and cutting your teeth on
Yeah,
slogging away, listening to podcasts, soldering, like 100 boards. There's
yeah,
a feeling of accomplishment you get after that I think is important and satisfying.
yeah. Definitely, definitely. So where can people find out more about you and watch your work?
The best place is my YouTube channel where I post every other Saturday. So every 2 weeks I'll post a video. It's youtube.com/Steven the Robot, Steven spelled with a PH. That's pretty much the best place to find me. That's where 99% of my work goes into, is making videos showing what I'm working on. So yeah, that's probably the best place.
That's great. And you mentioned there's a channel as well for some of your supporters that can sign up and join in the pick and place fray as well.
Yeah, exactly. There is a Discord channel associated with the YouTube channel as well, or Discord server. And you can pop in and, tell me what I'm doing wrong or ask for advice. There's a great community of people there now that'll, help you with your board design and all kinds of stuff. And it's a good gang. So yeah, I got that
That's
too.
Great. That's great. All right. Well, thanks so much for joining us and telling us about your pick and place. And looking forward to, I'm going to send you a board at some point and just have you place
That'd be great. I'd love the challenge. See if I could do it.
Okay, great. Wow. 01005 components. Here we come.
Get back to me in like 4 years. Okay. Thanks for having me on, Chris.
So, episode 2 of the Contextual Electronics podcast is over. That was Stephen Hawes showing you all about the DIY pick and place that he's building and all of the stuff that he's doing to put into that, integrating mechanical, electrical, and software, and really showing you everything he's doing, which is great. We would love to hear more about what you want to see here on this channel. You can always email podcast@contextualelectronics.com. We'll have the email down below. And we'll also have links to all of the things that Stephen was talking about and where you can find out more and follow him along on his YouTube channel. If you'd like to see more videos like this on Contextual Electronics, we not only do podcast videos here, we also do videos about KiCad and how to use PCB software. If you don't know, Contextual Electronics is a program where we teach you how to build electronics, not just KiCad, but also how to actually go and pick out parts and do soldering and use test equipment and all of the things you might need to do around building your own custom electronics. So that's what we're doing. We do project-based learning, and we're really enthusiastic about that. So if you haven't, please subscribe to the channel here. If you're more of an audio person, you can always go and subscribe. There's an iTunes link down below as well, and you can always subscribe in any of your podcast listening apps that are out there. Lots of ways to consume the content here, and if you don't see what you want, please feel free to shoot us a Twitter message. We'll have links to our Twitter, or send us an email, podcast@contextualelectronics.com. Thanks for watching, and we'll see you in the next episode of the Contextual Electronics Podcast.